Alright, hi class. What I'm going to do here in this video is help you see an example of a problem that you're going to be practicing, and that is how to take a polynomial of higher degree and write it in its linear factorization. Now that we know about both real and non-real factors or roots, we can do this with any polynomial. So the first goal is to use our graphing calculator to find any real zeros. We need to know the real ones so that we can do some synthetic division and get down to a quadratic. So what I did is I took this degree 5 polynomial and I put that into y1 in my calculator, and then I set y2 equal to 0. That allows me to use the intersect feature and find where these two, where my polynomial intersects the x-axis. So where are my real zeros? And what you'll notice is I actually found 3 of them. I found that one of them occurs when x is -2, one of them occurs when x is +1, and the other one occurs when x is 4. And what you notice is those are the only 3 times that my graph crosses the x-axis. That means those are the 3 real roots, which also must mean that I have 2 more, or a pair, of roots with non-real parts. So now what I'm going to do is I'm going to take my polynomial and I'm going to use my 3 real roots, and step number 2, I'm going to do synthetic division, in this case 3 times in succession, because doing it 3 times is going to take that 5th degree polynomial from a 5th degree to a 4th degree to a 3rd degree and then to a 2nd degree, or a quadratic, and then I can either factor it or use the quadratic formula. And then note, and I've already said this, because this is a 5th degree polynomial, there's got to be 5 total zeros. Since 3 of them are real, we know there's going to be 2 complex ones. Those are the ones we're going to find last. So the next thing that I'm going to do is some synthetic division. It doesn't matter which of these I start with. So I'm going to take my coefficients, and I can pick any of these roots to start with. So I'm going to start with +4. And now I go through my synthetic division process. Pretty exciting. And sure enough, my remainder is 0. Now, I don't have to do anything with my coefficients. I've now taken it from a degree 5 to a degree 4, and I can go ahead and I use this guy. Now let's do synthetic division again using +1. So I go through my process of synthetic division, and I'm looking for a remainder of 0, and I get it. Now I've got one more real root to use. So I do my synthetic division. Again, looking for a remainder of 0, and I get it. And that tells me that I now have a quadratic. And step number 3 says, now that you have a quadratic function, factor it or use the quadratic formula to find the remaining complex zeros. So here is my quadratic, 1x squared minus 6x plus 13. I'm going to set that equal to 0, and I'm going to use the quadratic formula to find the remaining zeros. So x is equal to 6 plus or minus the square root of 6 squared minus 4ac, so 4 times 13 is 52, all over 2, and I keep going. 6 plus or minus the square root of 36 minus 52 is -16, all over 2. This is going to be 6 plus or minus 4i over 2, or 3 plus or minus 2i. So now I have my last remaining roots, my complex ones. So step number 4, to finish it off, it says use all zeros and write the function as a set of linear factors. Remember, I had real zeros that were, I don't even remember them. Let me go back. 4, 1, and -2. So 4, 1, and -2. And now I have complex zeros that are 3 plus or minus 2i. So I have 5 complex zeros. That means I'm going to have 5 linear factors. x minus 4, x minus 1, x plus 2, and then my complex x minus 3 plus 2i and x minus 3 minus 2i. I have now taken that degree 5 polynomial and written it as a set of linear factors. Hope that helps. Have fun!